So we are graphing tangent and cotangent today. They're a little bit different than the other ones we've been doing. There's some similarities, but they are different in some ways. So I'm not going to have you guys copy this slide. This is just for discussion purposes here. Hold on a minute. You probably wouldn't have unit circle review time. So we're going to do tangent. We're going to notice the angles are different. That's one of the differences. You know, for sine and cosine, secant and cosecant, we've been using the same angles every time. 0, pi over 2, pi, 3 pi over 2, and 2 pi. That's a good set of angles to use for those because it completes one full cycle in that interval. Tangent, that's not a good set because you won't see a good cycle within that set. So what you want to do instead is use these ones. So I'm picking a different set of angles so you can see a full cycle of tangent. So here we go. Where is negative pi over 2 located on the circle?
In the bottom right quadrant.
It's at the very bottom. Now tangent, you got to think of your tangent circle. What was tangent down here? Good memory. All right. That means on the graph, that's going to be another vertical asymptote, right? All right, next one. Negative pi over 4 is here. Now, all of the tangents in the middle were what number? They were all 1. Some of them were positive and some were negative. Do you remember what this one was? It was a negative. So this one's negative 1. How about at 0? What was tangents?
0.
It was 0. How about at pi over 4? Just 1. And how about pi over 2? Undefined again. So I'm going to graph this really quick. But over here at negative pi over 2, notice it's to the left because it is a negative angle, right? We're undefined, so we have a vertical asymptote. At negative pi over 4, we're down at negative 1, like so. We'll just put that right about there. At 0, we're at 0, and then at pi over 4, we're up 1. And then finally, pi over 2, we have another vertical asymptote. That's only 3 dots. It almost looks like a straight line, but it can't be because it's got to get flat up here against that one. So how tangent looks is like this. It's from this point to this point, it's concave down. And from this point to this point, it's concave up. And then after that, you just kind of try to squish up against those asymptotes. And that's what a tangent graph looks like. Sure.
You know when you do the views?
Yeah.
How many are you gonna add? Like,
how many cycles do I want to see?
Yeah.
That's a good question. Okay. So I'm going to do the same thing here. I haven't forgot yours. I'll come back to you in a minute. But so the question is like, you know these are periodic, right? So like sine and cosine, it doesn't stop here. It just does it again, right? And so Taya's question was just, well, how many do you want to see exactly? Well, so long as you have at least one to the left and one to the right, I'm good. Because I want to know that you know that the cycle is infinitely continuing in both directions. So if you give me one on the left and right, that tells me at least you know it keeps going to some extent. Now your question was, say that again. So we had those 3 dots, right? So from here to here is concave down. That means it bends down. And then from here to here, it's concave up. And then the rest of it just goes straight up, and you want to get close to that asymptote. Okay. Those are hard to draw. I find a lot of students have it'll be interesting. Take a look at a few of your peers' papers as we draw these today. They come out looking really interesting. It's a hard one. I have a hard time drawing them, honestly, too. I don't know what it is, but there's something about that shape, getting all those dots to connect and get that shape. It's challenging. All right. So Cotangent does the same thing, and you won't be surprised to realize that it looks pretty much the same. You're going to notice something though. I've picked different angles once again. To see a full cycle of cotangent, this would be a good set of angles to start with. What do you guys predict cotangent might turn out looking like? It's just going to be going the other way. Okay, it's the reciprocal of tangent. So I think to save some time, we'll just kind of I'll let it go, but I'm not going to go and fill it out and work it out. But it ends up looking exactly the same. You're going to have undefined here, you're going to have undefined here, and then you're going to have it work out so that whenever you get your graph, instead of going up this way, it ends up going down that. That's the only difference. Okay, so let's go ahead and have you guys copy down this slide. Some things you guys are going to want to write down while you're getting these slides is the fact that this is tangent and this is cotangent. I should have had those labeled, but for some reason I did not. Another thing is you'll want to make sure you get these little measurements on here, like this is negative pi over 2, negative pi over 4, 0, and so on. So I'm going to make them a little bit bigger and darker so you can see them better. The other thing you're going to want to get is the dots that are on there. I'm talking about these dots here. There you go. So I'll wait a little while you guys copy that. Yeah.
Are we going to get marked down for not labeling the x-axis?
So for now it doesn't matter. Well, I would say starting today it might be a good idea to start labeling because now we've got different ones, right? So for sine all the way up to secant, those ones that we've been doing for the past 2 days, I kind of didn't care because they were always the same, right? But now you see we start getting some different things. So I would say from now on, yeah, definitely. And it's going to get even more different a little bit later on. So it's probably from here on out it would be good to start labeling.
Oh, I don't know.
All right, here's something for you guys to copy here. So go ahead and get that down. Okay. So when we were doing sine and cosine, this number told you our midline, right? Well, in this case, it tells you where your midpoint is at. I don't really think it's good to call it a midline. It's more like a midpoint. So, in other words, whoa, see, I screwed that up. Looks like this, right? Tangent. The midpoint's the one right in the middle there. So it tells you how far up that dot's going to go. Okay. This number here was our amplitude with sine and cosine, and it kind of does the same thing. It instead of telling you how far up to go from the midline, it just tells you how far to go up and down from the midpoint. So I'm not going to call it though the amplitude. I'm going to call it the vertical stretch because amplitude applies to waves. That's a wave word. And these aren't waves, obviously. So we're not going to call it an amplitude. We'll call it the vertical stretch here. It's not like the sine and cosine waves, right? It's like a weird. Yeah. All right. So it tells you. Remember those other two dots that we were talking about on the other slide? The A tells you how far up to get to those dots, or how far down you have to go to get to those dots. So it's the stretch factor. All right. The next slide is there's a lot to write, so stay focused and write with us. It's steps on how to graph. So guys, these are the steps that we're going to use. I'll give you a brief little overview of how they work, and then we'll actually apply them. So the first thing you got to do is you got to set up your graph, right? And now we're dealing with different angles. So you need to decide what set of angles are you using. If you're using tangent, you use one set. If you use cotangent, you use another set. It doesn't matter to me whether you use degrees or radians. these are the same thing in degrees and radians. So either way works. After that, once you get your angles set up on the graph, you're going to go ahead and put your asymptotes on there. That's step 2. Step 3, we're going to find out where the midpoint is. Now, usually the midpoint's like in the middle, right? But since if there's going to be like a plus k on there, that might shift it up a little bit. Okay. From there, we're going to decide which way is it going. Is it a tangent one, so it goes up, or is it a cotangent, so it goes down? Today, we're only going to do tangents, so the ones we're doing are going to be going up this way. And the next thing we have to do is ask how far up and down. That's what the vertical stretch factor tells us. So however big that number is, that tells you how far to go up and down from there. And then you go ahead and connect the dots, and that's pretty much it. So that's the big picture view. Let's go ahead and put it to work for us. Oh, what'd you need?
I'm literally like right there.
Go ahead. Oh, the marker's gonna. So there's one over there. I think Allison's out. Yeah.
Okay.
You're okay. Go ahead. It's fine. All right. Shall we go? See another pencil movement. I can wait a little more. I know, go on. Okay, looks like we're good. All right, write down number 1 here. You can leave the directions out because I don't care if you use degrees or radians at the moment. So just go ahead and write down the equation. So we're going to graph 2 tangent theta minus 1. I'll write it again here. So we're graphing y equals 2 tangent theta minus 1. Okay, so step 1. You guys read your steps to me. So who wants to be my reader here? All right, Allison's going to be my reader. You guys should read along with me. So what does step 1 say?
Set up your graph with theta values below.
I like it. I like it. I'm going to give you an audition for the next Siri voice.
Thank you.
All right. Now, at this point, you have to make a decision. Is it tangent or cotangent? Well, we're doing tangent, right? So which angles am I going to use, Allison?
Negative 90, negative 45, 0, 45, and 90.
Hey Siri.
Crystal clear. Crystal clear. All right. So, next step. Hey, Allison. What step? Read me step 2, please.
Sketch the asymptotes at the first and fifth theta values.
There we go. So sketch your vertical asymptotes at the first and last theta values. Okay, now the next step's a little bit confusing. I'm not going to ask Allison this time. I'm gonna say it, and then I'm gonna let her read it afterwards because the directions themselves aren't horribly clear. So the next step is to plot the midpoint. Now usually the midpoint goes right here, right? But I got a vertical shift, don't I? So I'm gonna go down 1. Okay, so I'm gonna have a dot right here. This 0 confused people in my last block, so I'll get rid of it now. But that 0 is for the angle here. So this is down 1. All right. So what did I actually write there, Allison?
Plot the k value at third theta value.
Oh, plot the k value at. Okay, good. So plot the k value at the third theta value. Okay. Now, since we're doing tangent, it's going to be going this way. So as I go over, I'm going to go up this way. And as I go to the left, I'm going to go down. Does that make sense? But the question is how far up and down. And that's what this number tells us. That's our vertical stretch. So I'm going to go over 1, up 2. And over 1, down 2. So over 1, down 2.
I thought it was up. Wait.
So to get to the next point, you always have to go over. That's always been the case, right? Even when we're doing sine and cosine is like, remember that? You always move over. So it's the same thing. To get to your next point, you have to move to the next angle. But the question is just how high up is all that matters, and this number tells you how high to go. So we went up 2 spaces because this is a 2. All right, so now we get to connect the dots. Remember, this side's going to be concave down. This side's concave up. And then try to squish it up against the asymptote as you go. And just to indicate to me that you do realize this is a periodic function, which means it repeats, I would like you to give me 1 to the left and 1 to the right. You can kind of ghetto sketch those ones. They should look roughly similar to the middle one. Ghetto sketch. Which means I'm not going to try to be very precise about where the dots are. I'm just going to make it look roughly the same. All right.
So I don't have to take notes in there.
I don't speak but, T. All right, there's yours. Ah. Good wait. There's no G. Write down this one really quick because Alex wants me to go back really quick. I'm going to go back for it. So write down the equation. This is your guys' student practice. Oh, I don't care if you use degrees or radians. Either way is fine for me. For now, I don't care. You good? You guys all got it written down? All right, I'm going to go back. All right, so yesterday we did the tangent graphs. We're going to do this cotangent one now. It's pretty similar. Hopefully you guys have your notes out and can see the steps that we wrote down to kind of keep it fresh in your mind. So if you guys got those out, you might want to look at them. So what does the first step say that we wrote down for graphing these things, guys? Set the graph up. And that basically means, draw your graph and put the angles that you're going to use on there. So we're doing a cotangent graph, and it's asking us to do it in radians. So what angles would I use if I wanted to do this in radians? There you go. Thank you. There you go. So for cotangent, it's either going to be 0, 45, 90, 135, 180. If you're doing degrees, or it's going to be those in radians. Since the instructions ask for radians, we'll do radians for now. What does step 2 ask us to do? Asymptotes, and they're the ones at the beginning and at the end. All right. And then the next one tells us to plot the midpoint, right? Using the k value. So what's our k value for this? Let me see. I consider it was like 1/2 cotangent theta, and that's it, right? Okay, the k value is the number that's being added over here. So what is that? Yeah, so it's kind of confusing. The one, if you're missing the amplitude, it's 1, but if you're missing the midline, it's 0. Okay, so you're right though, was missing, so it's 0. So that means I'm going to plot my midpoint right on the x-axis. Okay. Now the next part is a little bit complicated as well. You have to ask yourself, okay, what direction is this thing going to be going in? Is it increasing or is it going to be decreasing? It's decreasing. Look at your steps. Cotangent goes down from left to right, correct? So now that we know that, we're going to have, when we put the stretch dots over here, it's going to have to be over and up this way and over and down this way so that it goes downwards. If it was tangent, we would go the opposite direction. All right, so What we do is we use this number here to find out just how high up we go from the midpoint. So if I call this 1, then half would be like right about here, right? So I'm going to go over 1 and up a half, and over 1 and down a half. Guess I should put negatives in here too. So there it is. And so once again, you're going to connect these two with like a concave up, slightly, not too concave, but slightly concave up. You're going to connect these two with a concave down, and then you can go ahead and just stretch the rest up to the asymptotes. And that's a cotangent graph. Same thing as tangent, it's just that you got to remember it's decreasing instead of increasing. It has the same exact steps involved. And of course, we always want to do at least one more option to the right and one more period to the left, just so that we know that it keeps going. Yeah.
Why should you plot it on the
I believe the steps say at your third angle, plot the k value, right? So this is my third angle, and the k value is 0. So at the third angle, I put it at 0 for the y. All right, so I'll let you guys practice a cotangent, and then we'll move on to something new. Try number 2 there. See what you get. Well, I don't like how I gave you the same amplitude. I'm going to change that just so we can vary it up a little bit. Too much of the same thing is kind of pointless. Let's do let's just make it like a 2. There you go. Tangent theta. All right, so let's try. All right, so we're going to be using the same angles we used last time, so there's no big surprise there. We're going to have the asymptotes at the same spot once again. No big surprise there. Iman, what do I do next, though? Here things do get a little different. That's right. Plot the center point. And how far up or down do I put it? Down 1. So I'm going to go down 1 and put it right there at that third angle, down 1 space. Armando, if I were to go over this way, which way do I go, up or down, and how far?
You go down, and you go down to.
That's right. So down 2. Okay, so first of all, we have to go down because we're decreasing as we go from left to right. So that's why we go down. And we go down 2 because that's the stretch. Then you got to do the opposite, going the other direction. So over 1, up 2. Put you right about there. This side would be slightly concave up. This side would be slightly concave down. And then just stretch it up after that. And then try to copy it to the other side as best as you can. And we're good to go. That's tangent and cotangent. So that's what they look like. Let's talk about reflections now. I wonder if I have anything on this slide. Don't. All right, so as you guys know, tangents looks like this, right? Let me make it smaller though. Tangent looks like this. We'll call that f of x for now. So let's reflect that. If I were to flip that thing upside down, what would it look like?
It'd be like,
Yeah. So it'll have the same shape as the cotangent one. Whereas cotangent, I'll call it tan. Let's say g of x represents cotangent. As you guys know, cotangent looks like this. If I put a negative in front of it, that flips it over, and it will look like a tangent function. So basically, if you put a negative in front of it, it has the same direction as the reciprocal function. The thing is, though, is that it doesn't make it a tangent. Like if you flip a tangent function, that doesn't make it a cotangent function necessarily, because remember, tangent still starts at negative pi over 2, right, and ends at positive pi over 2, whereas cotangent still has a different starting point than that. So even though they will have the same shape, they will still have different starting points. But the big takeaway there is that when you flip a tangent, it looks like a cotangent. When you flip a cotangent, it looks like a tangent. Okay? That's pretty much the gist of it. So, those steps that you guys wrote down, is anybody writing this? We're good? All right. So, the steps that you guys wrote down yesterday, I want you guys to add something to it. I want you guys to add next to tangent a negative cotangent here because they will have the same direction. And next to the cotangent, I want you to put a negative tangent. Okay, ready? Let's do one. All right, set up your graph. We'll kind of treat this like a guided practice. Set up your graph.
Do you want us to do this in regions?
Let's do, what do you guys want to do?
Trig.
Got a mixture. So it doesn't matter which one you did. It's all good. Brooklyn, I'm going to go with what you did. Tell me the angles you used.
Wait, what do you mean?
Like when I say set up your graph, that means you're putting angles on here.
I use negative pi over 2, negative pi over 4, 0, pi over 4.
And why did you choose those numbers?
Because
Because it's tangent. Good. Now you could have also chosen to use negative 90, negative 45, 0, 45, and 90. That would be fine as well. All right, next one. We're going to put up our vertical asymptotes. So Melanie, where do I put my vertical asymptotes? Mm-mm. Try again. Well, asymptotes always go in the first and the last one. So that would be here. and there. So the first angle and the last angle. Okay. Now with cotangent, it does start at 0, right? But we're doing tangent right now. So it's always, and the same thing applies for cotangent, that it's always first and last. They just start with different angles. All right, so Juliana, where am I gonna put my midpoint? Up 3. All right. So here I'm going to stop, and I'm going to let you guys see if you can get the rest. Go ahead. But I'm going to remind you to watch out for something here. This is a negative tangent. Okay. All right. So that's that. But there was one more thing that I need to squeeze in here, and then we'll call it a day. You don't need to write a lot until the last slide of this next thing I'm going to bring up. Just observing for the most part. I'm going to leave this in the non-presentation view because I need to be able to manipulate things. But do you guys remember what? We know that this reflects it, right? Flips it upside down. What does that do? Flips it horizontally. Okay? It flips it horizontally. All right, so we're gonna start embarking on looking at horizontal transformations. We're only looking at verticals. Those ones are a little bit easier. Horizontals start getting a little bit weird, and we'll spend all of next week on horizontal transformations for these things. So we're gonna do the first one today, which is reflections, and we'll see what kind of an effect it has on the graph. So here's a graph of sine x, right? We are used to this thing starting at the origin, or the midline, right? And then doing what afterwards? Going up, right? Now, if I flip this thing sideways, it still starts at the midline, but it goes down. Just like when you do a vertical reflection, same thing. So it actually, with sine, a vertical reflection gives you the same exact graph as a horizontal reflection. So there's that. So sine goes down afterwards. But let's go ahead and continue the journey here and look at other ones, because they're all a little different in their own way. Let's look at cosine. All right, so cosine usually starts where? Hello? Cosine usually starts at the top, right? But if I reflect this thing horizontally, put a negative inside on the angle, where does it start? It didn't change. You guys see how it's identical? So that one's weird. It doesn't play like sine does. It works a little bit differently. It's symmetrical. So when you flip it horizontally, nothing happens. Okay? So what we saw with sine is that a vertical reflection is the same as a horizontal. They both cause it to go down. But with cosine, a horizontal reflection is not the same as a vertical. A horizontal is actually just the same as the original function itself. Okay? Tangent. What do you think is going to happen if I make tangent a negative? Is it going to stay the same or be different? It's different, right? It looks like a cotangent. So once again, a horizontal is like a vertical for this one. How about for cotangent? Same thing, right? If I flip it, it reverses its direction. So once again, a horizontal is like a vertical. And notice I haven't said anything about secant and cosecant, and that's because they're just going to follow whatever sine and cosine do. Okay? All right, so this is the slide I would have you guys write down. Let me talk about it first, because I'm gonna give you guys a while to write it, but I want you guys to have a picture that goes with it. So if you have a sign with a negative in front or out or inside the parentheses, no matter what, you start at the midline and go down. So we're going to draw a picture for that. So it starts at the midline and it goes down. Okay? Put a little arrow there for going down. Cosine, and whether it has a negative inside or not, starts at the max is what we saw. So negative cosine is different. If you have a negative in front of the cosine, it actually flips it upside down. Now negative tangent, tangent with a negative inside, so a vertical, a horizontal, both look like a cotangent. Both of them decrease in that way. Whereas a negative cotangent or a cotangent with a negative angle is the same as a tangent, which are increasing. So there you guys go. I'll let you guys copy that now. Okay, so that's a lot to remember. I'll show you guys a couple of things you can do to kind of help yourself with this and not have to weigh down your memory so much. Yeah?
So is this test going to be multiple choice?
No, this test would not be multiple choice at all. So it's all sketching. Yeah, 100% from beginning to end. Yeah, no, it's not multiple choice. Anyway, back to the point. There's a lot to remember here, right? And so that's kind of taxing on the memory. Like if you actually sat down and just tried to memorize that, that's a lot. I don't. I'll show you guys what I do, and this is what I would recommend you guys to do yourselves, but it depends on how well you know your transformation rules, right? So all I do is I remember 3 graphs. I remember that sine starts at the middle and goes up. I remember that. I remember that cosine starts at the top. And I remember that tangent looks like that and it's increasing. Okay? That's all I need to remember, because after that I got the rest. So if I see this, I remember, oh, that's a vertical reflection, and I can, well, it's not going to let me do that. Let me back up. I remember, okay, that's a vertical reflection. So I just mentally in my mind imagine what that would look like if I flipped it upside down and say, oh, now it's going down. Okay? Or if I saw, clear all that out of there. If I saw this, I would see in my mind, okay, they want me to flip it sideways, and now I see, okay, it's going to flip that way. But you got to be able to see that in your mind to do that. But it saves you a lot of trouble of having to memorize things. So if you just remember negative outside means upside down, negative inside means sideways, you got that. As for tangent, same thing, but I just, I don't bother to remember the cotangent graph, honestly. I just remember that, oh, it's just flip of tangent, right? So really all you need to know is 3 things, and if you can just do the mental work based on the reflections yourself, it could save your cognitive load. Now another thing that you can do is you could always just plug a number in and see what you get. You know what I mean? So like if you don't remember where sine starts at, plug in 0. You should get the midline dot. And then plug in the next point, pi over 2. You should get the next point, and after that you can follow your pattern. So you can just plug in numbers, and you can always do that as a backup. My last suggestion, which I wouldn't advise, is to just actually try to memorize that whole list that we had on the last slide. That's a bit much, that's too much to memorize. But best thing is to be able just to understand transformations and know those 3 basic graphs. Second best would be to, well, just plug in some points until you get the shape you want. Third recommendation, well, I guess if you got to resort to memorizing a list, you can, but that's a lot to remember. So that does it for us. We're done for the day. Finished a little early once again.